Good morning to the three people that have joined so far. I would appreciate it if you would turn your video on. Thank you, Annalise. Everybody is muted when you join the meeting, so that's fine, but I like the video should be on. Thank you. Expecting 13 students in this section. That's 9. Video's on, please. Thank you. So what's that? 11 minus 1, 3 more I'm expecting. Give them maybe another minute. All right, so it's 7:56. I think I'll get started. Good morning. My name is Bob Storer. I am the professor of ISE 111. This is a class on probability. And as I think I've warned you before, but just to warn you again, these record automatically from the beginning. So there are recordings of the class. Today, I just want to go through the course site that I've set up and then go through the syllabus, talk about what we're doing in the class, how we're going to grade it, what the expectations are, and things like that. At some point, I want to test the whole breakout room thing. It's something I haven't ever used before. I just want to see how it works. One thing I'm not sure about is how it assigns people to rooms. If it does it, randomly every time, or if it'll be the same groups for the whole day, or if it'll be the same groups for every meeting. That's what I'm curious about. I want to do a little test with breakup rooms, and then when we've gone through sort of the details for the class, go through some initial probability problems just to give you some idea what's going on here. All right, so Jose, please turn your video on. Okay, so I'm going to share my screen for the course site, if I can find it. Where is it? Come on. Hold on a second. Okay. All right, so this is what we have so far. This is the survey. Pretty much everybody took it as requested, so I appreciate that. We'll go through the syllabus in a minute here. I don't quite have a schedule yet. I'm still trying to figure that out. This folder contains, oops, that's not what I wanted to do, sorry. This folder contains all of the PowerPoints that I use in the lectures. And this folder contains class notes. So this is like in written form, like in a Word document instead of a PowerPoint. It has basically the same information as the PowerPoint slides, perhaps a little bit more verbiage in there. But the PowerPoint slides were all derived from these files here. So it's kind of more readable, if you will. And then we have a forum for the class. This is also something I haven't used before. We'll talk about that a little bit later. So I have 3 different links. So we have TAs in the class, so they're going to have office hours. And I'm going to have office hours. And these are set up slightly differently. So they have waiting rooms and things like that. And they don't record automatically. This is the one you're on now. And so the thing is that it records automatically. Then we're going to talk about expectations for the first 2 weeks. So that's basically the schedule and what the assignments are. And then this data here has something to do with the forum. All right, so next I'm going to attempt to share the syllabus. Where is it? Hold on a second. Okay. So this is the syllabus is posted. The first thing, just talk a little bit about probability. What is probability? A lot of times you hear the words probability and statistics together, like this is a class in probability and statistics. That's not the case here. This is a class in probability. So in industrial engineering, we separate 2 classes. First, we have ISE 111, which is probability, and we have ISE 121, which is statistics. And the 2 things are really quite different. So the main difference is that statistics pertains to analyzing data, in particular analyzing sample data. So you collect data, you sample data about some question you would like to learn the answers to, and then you use that data to make inference about the population from which the sample was drawn. So it's inherently sort of an inductive thing, right? We're trying to make conclusions from samples from data. So unlike statistics, probability theory is not like that at all. It's inherently deductive. So it has nothing to do with sample data. Although in this class, we will use examples with sample data because probability and statistics are tied together. Probability is more like math, right? And it's like math in the sense that results and conclusions are derived from propositions and assumptions, all right? So a typical example of a probability problem is this. Given that the probability of a coin flip coming up heads is 1/2, so that's the assumptions we're going to make. Probability of a head is 1/2. What is the probability I will get exactly 5 heads if I flip the coin 10 times? All right? So given an assumption, we're trying to deduce a conclusion, right? So given that the assumption is true, the conclusion is absolute. It's mathematical. It's not based on sample data or anything. Okay, and if you're curious, the answer to this problem is about 24%. This is a kind of example you'll be able to do fairly soon. So both probability and statistics are useful. In truth, statistics is probably the more useful of the 2, although engineers do use probability as well. And we'll certainly see examples of that in this class. But the other reason to learn probability is that if you don't understand probability, you will not understand statistics, because statistics is based on probability theory. And that's the other main reason why we study probability. So if you're an industrial engineering student, probability will affect you in 2 ways. You'll need to know it when you learn statistics, and will also take more advanced probability classes that are also useful. For example, ISE 230, 230. All right, so probability theory can be fun and interesting, but it can also be difficult, confusing, and frustrating. And one example of this is something that we're going to learn probably starting around the third week of this class. The topic is counting, and it was kind of amusing because counting sounds pretty easy, right? You know how to count. Turns out that the counting methods that we often use in probability are very complicated and complex. And so what you're going to find that in this class, the first 2 weeks are kind of introductory material. It's pretty straightforward and easy. And you're going to be saying, yeah, I got this. And then all of a sudden we go into counting, and you're like banging your head against the wall because it's complicated and difficult. And then you say, oh, wow, the class is going like this. And I'm really worried. But what'll happen is that after counting, it'll kind of even out and come back to a kind of an even keel. So be forewarned, the counting part in the weeks 3 and 4, probably the hardest part of the course. All right, next in the syllabus, sort of basic, course objectives, things I want you to learn, but also these down here, right? Develop curiosity and healthy skepticism about assumptions. Be able to identify the necessary components of a model, and hopefully be able to create value by understanding how to apply probability theory. Now, this is one of the key parts here. So how are we going to do this course? So this course is going to be in a flipped classroom format. The good news is I've done this before. The last couple of years, this is the way I've been delivering this class. So it's not the first time I've tried this. So the way the flipped classroom works is that you guys will watch the appropriate lecture in advance of the class. All right? Then during regular class hours, not today, but starting on Wednesday, we'll discuss the material that you've watched, we'll answer questions, we'll work on group exercises, and things like that. So it'll be more of a discussion and some kind of small sample problems. And for these group exercises, we'll use the breakout rooms. We'll break up into groups of probably 2 or 3, give you 5 minutes to discuss the problems. Then we'll come back and I'll use a random name picker to pick somebody to present your answer. And then also each group will turn in their answers to these problems, okay? We'll have a link for that. So here's the sort of the deliverables. These are the things that the grade for the class will be based on. First of all, when you start watching the lecture videos, you will see that there are quizzes. These are short multiple choice or true false questions. Might be 4 or 5 questions, might be 1 or 2 questions, but in each video there might be 4 or 5 quizzes embedded. So the way that these videos work is you'll watch the video up until a quiz, and then you'll take the quiz. In order to continue watching the video, you have to complete the quiz, all right? And you only have one chance to do the quiz, right? You won't get multiple choices, you get one chance, okay? Once you complete the quiz, you can move on. The quiz scores are automatically recorded. I can see them, and we will use the results on the quiz as part of your grade in the class. All right, but again, you can't continue on into the lecture video until you've taken the quiz. All right, so like I said, I can see the quiz results. I can also see when the quizzes were completed, right? And so, I mean, I can't prevent you from taking the quiz late, but I will know that it's late because it also in the data I get is a timestamp, right? So the deadline for completing the quizzes is the time of the class that you're supposed to have watched the video for, okay? So that's one way to enforce accountability, that you are watching the videos, the lecture videos, in a timely way before the class that you're supposed to watch them for. Okay, I mentioned that there are these group exercises that will be done during class, and you're expected to turn those answers in as well. Now, I'm a big fan of exams, but I haven't figured out a way to give a typical exam in a way that I'm comfortable with online. So typically in this class, we would have 3 exams and a final. What I'm going to do instead is I'm going to have maybe every couple of weeks or so, I'm going to have something that you might call a small exam or a big quiz, however you want to look at it. We'll use the course site tools for doing it. And you'll have, it'll be a timed quiz with a certain time frame within which you have to take it. All right, number 4, we're going to have homework assignments, roughly 9 or 10 of them. And instead of a final, we're going to have a project. And I'll probably have the project done in groups. I haven't decided, groups of 2 or 3 most likely. Class participation is a big part of the grade. So that involves actually showing up for class like you did this morning. And by the way this is going to be monitored is that the TAs will watch the recording of the class and see who showed up. It involves you actually participating in class, for example, in these group exercises and things. And also hopefully participating in the class forum. So again, we'll talk about this. This is something I haven't tried before. We'll see how that goes. All right. I guess I should say, if you have any questions, I guess you can unmute yourself and speak up, or I don't know, maybe that raising that hand thing or whatever. Probably would be easiest when I'm in screen share mode to just speak up. Okay, so next, prerequisites. Math 22 is a prerequisite, and hopefully you are currently either in or have completed Math 23. We use some calculus in here. It's not a calculus class, so I mean, I don't go out of my way to make problems difficult based on the calculus that's in them, but you will need to know things like double and triple integrals eventually, which you learn in the beginning of Math 23, I believe. Okay, so here's contact information. We have 2 TAs, Samira and Hisham. I don't quite figure out when my office hours are going to be, but I'm certainly available. I will have plenty of office hours, I guarantee you, and also I'm happy to meet with you at other times. If you send me an email, we can set up an appointment. Okay, so textbooks, there's no required book for this class. I used to have one but I really didn't use it. So basically, this book here is the book that they use in ISE 121, the statistics class. So most of you will take ISE 121. There are students in the class that are not ISE students and therefore will not take it. So it's not required for this class, but if you feel like you want to have a book for reference purposes and you're going to take ISE 121 anyways, then you might think about buying it. Okay, big problem. So some of the homework assignments will have what I call a big problem. It's more extensive than a typical homework problem, requires some investigation on your part, and will be worth more points. We'll give an example of that later too, because there's one on the first homework assignment. Okay, so again, we talked about the different components of the class, the embedded quizzes embedded in the lectures, the group exercises we do in class, the quizams. So there'll probably be 6 or 7 of these in the course of the class. Homework assignments, final project, and then participation in class in the forum. This is what I have in mind. And the way I grade, I curve the final grades, right? So to be clear what that means, we add up all of the points for the whole class. So every student in the class will have total points in the class. Then basically I sort them from highest to lowest. And I assign something like 25% A's, 30% B's. Let's say 30% A, 30% B, 30% C, and then 10% other. All right. And I do it so that the GPA comes out to be about 3.05 for the whole class, because that is the average GPA in the engineering college. I'm not going to go through all of these typical difficulties, but probably the hardest thing about this class is one way to think about it is it's basically a word problem class, right? So the problem will be presented usually in the form of a sentence, and you have to kind of first translate that into math, and then do the math to get the answer, right? So it's typically a two-step procedure, and oftentimes the first step is the hardest, translating the words into math. So much like you, I was an industrial engineering student many years ago, although to be honest, probability and statistics has not changed much since then. And I took the exact same kind of sequence, right? First probability and then statistics. And for me, statistics came very easily. In fact, I like statistics so much, that's sort of the field I ended up going into. On the other hand, when I took probability, for me, it was very difficult. And it's the kind of thing that it kind of has to click for you, right? You know, you're banging your head against the wall for a while, and then hopefully after a few weeks, it'll kind of click, and you kind of say, okay, now I get how to solve these problems. I get how to do probability. So it can be a little frustrating, and especially at the beginning, but hopefully it will click for you if you keep working at it. Okay, this year, no final exam, but there will be a final project. And these quizams, they're like, for me, they're like small exams. And so you better take them, and you better take them on time, right? And then we have these sort of standard syllabus statements. All right. We got to go back to course site. And okay, so now I'm clicking on the forum for the class. And now I'll go back to share my screen. Okay, so like I said, this is something I have not tried before in my classes. So you're gonna have to bear with me as I figure it out. But this forum is a place for students to post, and it's participating. This is going to be part of your grade. You can participate any way you want. If you have a question, you don't understand something, you can post that. If you see somebody else post a question and you know the answer, or you think you do, you can try and answer the other student's question. You can post questions, just sort of general questions you have that you consider interesting, like, this is a question I have, it kind of involves probability. And so I'll just post it and see what people have to say. And I will be doing that from time to time. And this is my first example. And it's sort of a big deal these days, this question you hear all the time. So every day, many COVID-19 tests are given and results returned. And each day we get some numbers out of them. And basically the numbers we get out of them are the number of positive test results and the number of negative test results. All right, so from these numbers, basically you can get a few things. You get the number of new cases. The number of new cases each day is essentially equal to the number of positive tests. And we also get what's called the positivity rate, which is the number of positive tests divided by the total number of tests. Okay, so some have argued that the number of new cases has been rising, particularly in the July and early August timeframe, was rising only because more tests were being given. I think you may have heard this in the news. All right, so what do you think about this claim? Do you believe some or not? All right, so how would you approach trying to resolve this controversy? Who's right here? What issues enter into resolving this question, right? So that, to me, this is an interesting test. And it seems like one would actually have to look at the numbers to do this. All right, so for that reason, bear with me again. I did post some data, which I am now trying to open. And share the screen. Okay. So I actually posted some data on CoreSite. So here's the number of positive tests, right? So I think you all remember we were into March, it went way up, and then it kind of leveled out. It actually started slowly going down. And then sometime around July or so, it started going up very quickly again, right? So this is where there was a lot of controversy. Oh, everything is going south on us. Down here we see total number of tests. So you can see the number of tests given each day steadily increase, right? So you would expect more tests, more positive results, right? Now, I guess the question is this number of positive tests, does that account, can you account for that simply by the total number of tests increasing or not? So that's the question. So what are the issues in answering this question? What do you need to know? What do you need to look at? I just kind of find that to be an interesting question. Okay, next I'm going to go back to CoreSite and share my screen. All right, so you're supposed to watch these lecture videos. So where do you find them? All right, so this is the CoreSite page. If you go and scroll down and look on the right-hand side, there's this thing here called Panopto, right? Panopto is the software that I use to record all the videos. And if we hit click all or show all here, unfortunately, they're kind of backwards, right? So like the first lecture video you're supposed to watch is right here. If you click on this, the video will play. I'm not sure if I do that, if it will show up on screen share. All right, so this is sort of what, well, I'm halfway through. That's me. And as you watch, you'll go through this, you'll listen to the video, and eventually you'll hit a quiz, and then you'll have to take the quiz. Not sure if you can see this or not. At any rate, Just nod yes or no. Did you see me start the video? Okay, good. Back to the course site. Hold on a second. All right, so the next thing is the expectations for weeks 1 and 2. So part of the survey I gave, I asked you like for best practices you saw from other professors. I actually tried to incorporate all of the things that you suggested into the class. One of them was having clear expectations, right? So this is my goal, to be very clear about this and make sure communications is done well. All right, so I would like you to view that first lecture by the time we meet this coming Wednesday, 2 days from now. And obviously to complete the video, you'll have to complete all the quizzes that are embedded in the video. Again, to remind you, you only have one chance at each quiz. All right, so by a week from Monday, a week from today, I would like you to watch the second lecture and completed all the quizzes. All right, and by a week from Wednesday, I would like you to have watched part of the lecture on Monte Carlo simulation. It's called Lecture MC. Now, I don't want you to watch the whole thing because in the second half, we cover material that is a little bit more advanced. So specifically, I want you to view up till this point and complete the first quiz. And once you've completed the first quiz, you can stop. Okay? Number 4, there's a homework assignment that's posted. That will be due on September 2nd. That's Wednesday after next. And there's, of course, a link for you to turn in your answers. All right? Look into the forum. Hopefully post something on the forum, whatever you want to post. And then sometime in the 3rd week, we'll have our first quiz am. All right, so the next thing I want to do is any questions? I see a couple of no's and a couple of blank stares. And okay, no participation points today. Dead when I saw you say no. Okay, so that's good. I'll give you 1 point. What was I going to do next? Okay, so this is where I just want to do a little test. All right, I'm going to test the breakout rooms. I'm going to have 3 people per room. And I'm going to create the rooms and we'll see what happens. Okay, so it assigned. So open all rooms. All right, so can you guys accept the invitations to go to the breakout rooms? Okay, so now, breakout room 1, I can see you guys, so now I'm going to leave. Breakout room 1.
You're muted.
bad. Thank you. Sorry. Okay, so that worked okay. Now, the only other thing I want to find out is if I do the breakout rooms again, will it be the same groups or different groups? All right, so bear with me. I'm going to create breakout rooms again, and then I'll go look and see who's in the rooms, and then I'll end the breakout rooms and you'll come back, okay? Let's try that one more time. Oh, never mind. So I'm hit breakout rooms and I can already see that it's the same people in every room. So I won't even bother creating a new breakout room. I guess the only other thing that remains to be seen is next time we have class, will it be the exact same groups or will it be different groups? I suspect the answer is it'll be different groups. Does anybody know the answer? Will it be different groups the next time we have class or will it be the same groups?
I'm not sure, but I know that you can manage them and you can switch people between breakout rooms. So if you wanted the same groups, you could do that.
Yeah, thank you. It's real painful to do, right? In this class with 13, I might be able to manage it. It'd probably take up some time. In the class with 33 students, don't want to even mess with that. I don't want to have the same groups every time. I want it to be mixed up and I want it to be random or at least arbitrary. So I'm hoping, I don't mind having the same groups for one class. I'm hoping it'll create new groups every class. That's what I'm hoping for. We'll find out next time, I guess. Okay, so that ends my coverage of how the class is going to work. And next, I'm going to just talk about some interesting problems, probability problems. But first, I want to give everyone an opportunity to ask any questions you might have. Just unmute yourself and let it fly.
Hello, Professor.
Hi.
I was just wondering, will we be emailed the recorded lectures after the lectures are done?
Will you be emailed the required lectures? Are you talking about?
Oh, sorry. Like for example, after each class, would like how the lectures are being recorded now? Will we be emailed them after class so we could see them again?
So you're talking about what's going on right now, right?
Oh yeah.
Well, I am recording them. Yeah, they will be recorded. I was thinking I would post them on CourseSite. They're going to be very big in terms of the size of the file. I'm not sure how emailing will work.
Okay.
Is it okay to just go on CourseSite and grab them?
Oh yeah, that's perfect.
Okay. All right. Other questions? All right. I'm not seeing any other questions. Okay. So hold on a sec. I'm going to share my screen again. All right, hopefully you can see my slides. So the point of this is just to show you some problems that I think are kind of fun, but also maybe illustrate probability is not as easy as you thought, and it's not even necessarily intuitive all the time. Okay, so here's problem number one. Okay, the boss leaves 5 unique letters and 5 addressed envelopes for the secretary to mail. Unfortunately, the boss does not tell the secretary which letter goes in which envelope. Secretary randomly places letters in the envelopes. What is the probability that exactly 4 out of the 5 envelopes contain the correct letter? So think about that for a minute. And if you How many do I have here? I'm missing. If you know the answer, simply unmute yourself. You don't have to say anything. Just want to know who has the answer. Nobody has the answer. No? Okay, so this is an example of a probability problem where it's kind of like you either see it or you don't see it. Right? You don't have to do any calculations. 4 out of the 5 letters are in the correct envelope. 4 out of 5.
Is it 1 out of 5?
What?
Is it 1 out of 5?
It is not. Okay, I'm going to give you one more hint, and now I'll see, hopefully I'll see the mute buttons come up. 4 out of 5 are in the correct envelope. What's the deal with the last one? Come on, we see those unmute buttons.
So if 4 out of 5 are in the,
Whoa, just waiting for people. What's the deal with the last one?
It- can we answer?
No, not yet. I'm
Okay.
giving people another minute or two. Okay, so I'm going to restate the exact question. What is the probability that 4 out of 5 are in the correct envelope? Go ahead, Morgan.
Oh, well, if 4 out of 5 are correct, then the 5th one also has to be correct, right?
I'm not disagreeing with you, but you did not answer the question I asked.
The probability question?
I said, what is the probability that exactly 4 out of 5 are in the correct envelope?
Oh, I don't know.
It's 0. It's impossible, right?
Oh, okay.
So you were correct. Your reasoning was correct. It's just that you didn't answer the exact question. Okay? So maybe a little frustrating question there. All right, let's go on to the next one. See what we have here. Okay, this is a more straightforward problem. Okay, so you're at the car dealer has a game to attract customers. So he has 5 new cars and he has 5 keys, and each of the keys fits one and only one of the cars, right? So the way this contest works is the contestant randomly picks one of the 5 keys. Then next, the contestant randomly picks one of the cars, and if the key starts the car, then the contestant wins the car. Okay? So the question is, what's the probability that the contestant wins the car? And I'll give you 2 choices, right? Is it 1/5 or is it 1/5 times 1/5? You can think about this for a minute. Five keys, 5 cars. Again, you can unmute yourself if you think you know the answer, but don't say anything yet. People are still thinking. Okay, I think Jose Castillo, you were first. I'll give you a shot. What do you have to say? Jose, can you hear me?
Yeah.
You unmuted yourself, so I'm giving you a chance. What do you think the right answer is?
1/5.
105. You have an explanation?
Because once he chooses a key, the other keys don't really matter. It's just about like him choosing a car.
Perfect. That's exactly right. Well done. All right. Okay, this is a little bit more difficult. Okay, I have 3 cards. All right. One card is white on both sides. Second card is black on one side, white on the other side. And the third card is black on both sides, right? So you got first is white and white, second is white and black, third is black and black. So you close your eyes and you pick a card at random and out of a hat, and you put the card on the table so that when you open your eyes, all you can see is one side of the card you picked, okay? Now, suppose that what you see is a white card. In other words, the side that's facing you is white. So here's the question. What is the probability that the other side is that you can't see, that's down on the table? What's the probability that that's also white? Okay, so I think maybe so here's answer number one. We see a white side is showing, right? So that means we can eliminate card number 3 because that's what's black and black, right? So we know it's got to be either card 1 or card 2. All right, so it's a 50% chance it's card 1 or card 2. So that means there's a 50% chance the other side showing, the side that's down on the table is white, right? Because it's either card 1 or card 2. Okay, is that correct? Here's answer number 2. All right, so before we start the experiment, there's 3 cards, there's 6 sides, right? So we're going to randomly pick a card, put it down, and one of the sides is going to be showing, right? So it's random, so each of those 6 sides is equally likely, right? So we could, here's the 6 possibilities, right? So the first possibility, we pick card 1 and white side number 1 is up. Or we could pick card number 1 and white side number 2 is up. Or we could pick card 2 and the white side is showing. We could pick card 2 and the black side is showing. Card 3, black side number 1 is up. Card 3, black side number 2 is up. All right. Now, since we observe that a white card is showing, the only possible choices that are left are the ones, the first 3 up here, the first 3 where a white side is showing, right? So these are the 3 possibilities that remain. And in 2 of these, the side that's not showing, that's facing the table, is white. So now the answer is 2/3. And it gave you 2 answers. And the question is, which one do you think is right? Just hold up 1 or 2 fingers. Answer 1 or answer 2. More 1s than 2s. And a few. The only thing you can't do, Edwin, is not participate. Danny, take a guess. Everybody else says. Okay, so Philip, 1 or 2? We're waiting for you here. Okay. So the correct answer is 2. Now, am I surprised that many of you got this wrong? Not at all. That's the point of these problems. I'm trying to show you that these are non-intuitive problems and the probability can be quite difficult. So this is an interesting one. I don't think I'm going to spend a lot of time on it. But it's kind of timely given the whole COVID and testing and all of that. This has to do with tuberculosis tests, but it applies to coronavirus tests as well. So whenever you give a test like this, there's 2 mistakes that can be made, right? Because the tests are certainly not perfect. There are things called a false positive and a false negative, right? So false negative, that means that somebody takes the test says they are negative, when in fact they're actually positive, all right? So in this case, there's somebody who has tuberculosis, they take the tuberculosis test, it says that they don't have it, all right? So the typical false negative rate for these tests is 1%. I've actually been trying to find out what the false positive and negative is for COVID tests, and I'm having trouble finding out a good answer to that. Now, the other mistake is called a false positive, right? So this, what happens here is you do not have tuberculosis, but you take the test and the test says you do have it. So the test says you have it even though you don't. And for this particular test, the false positive rate is about 10%, all right? Now, so these things, by the way, are called the specificity is like 1 minus the false positive rate, and the sensitivity is like 1 minus the false negative rate. Now, the other thing has to do with the incidence in the population. So tuberculosis is very rare, at least in the population of the United States. So it turns out that only about 0.001% of people have tuberculosis, right? This is called sometimes the incidence rate, or sometimes it's called prevalence. Okay, so we talked about false positive and false negative. Is one of these errors worse than the other? So in the case of tuberculosis, the answer is, well, yes, a false negative is a much bigger mistake to make than a false positive, because if you have a false negative, you have somebody who has tuberculosis who's out there walking around spreading it, and they don't even know it, right? A false positive, you're not going to impact other people, only the person who took the test. And in that case, what you'd probably do is have the person retake the test to try and verify whether it was a false positive or a true positive. So false negative is much worse than a false positive. Now, the way these tests work is they're measuring the level of something in the blood, right? And there's like a threshold. So if the amount of stuff in the blood is above this threshold, we declare the test positive. Otherwise, we declare it negative. Now, you have to set this threshold, right? So if you make this threshold higher, there'll be fewer positives and more negatives. And if you set it lower, there'll be fewer negatives and more positives. And so you can move this threshold and you can trade off the false negative and false positive, right? So if you raise the threshold, there will be fewer false positives. No, I'm sorry. There'll be fewer false negatives and more false positives. So you can adjust, you can trade off the false positive and the false negative by changing the threshold. And that's how you get these rates. So we want the false negative rate to be small, because that's the big mistake, right? Where people are walking around and spreading TB or COVID for that matter. Okay. So now here's the question, and I'm not going to ask you to do it. We'll learn how to do this in maybe week 4 or 5. But you go to the doctor, have a TB test, and the test is positive. What's the probability you have tuberculosis? Should you be panicking, right? Should you be worried? All right, so here's kind of how this works. Just imagine 100 million people get tested. Of these, only 1,000 actually have tuberculosis, because that's the incidence in the population, right? Meaning we'll get 990 true positive tests, okay? This many people will not have TB. They'll take the test, 10% of them will get false positives, so there'll be this many false positive tests. So there's this many true positives, this many false positives. So the probability you have TB is 990 divided by this plus 990. So the probability you have tuberculosis is 0.0098%, right? So even though you got a positive test, it's highly unlikely that you have tuberculosis, okay? So this kind of math holds throughout many screening tests. But I want to be careful to warn you that the reason why, even though you had a positive test, there's a very small chance you have it, is because the incidence in the population is very small. And I would note that the incidence of COVID in the population is not very small. The incidence of COVID is, I don't know, 5%, something like that. Okay, so you cannot say this about a COVID test. If you get a positive COVID test, the odds that you actually have COVID are much, much higher than this. Okay, here's my favorite problem. Back in the day, there was this game show on TV. It was called Let's Make a Deal. And Let's Make a Deal, the star was Monty Hall. And at the end of each show, they played a game with a single contestant. The contestant kind of got to the finals. And there were 3 doors that were closed, right? And behind one door was a big prize, like a new car. Behind the other 2 doors were the booby prize, like goats, right? So one of the doors, there's a car behind. 2 of the doors have goats. And here is exactly how the game proceeded. First, Monty Hall would ask the contestant to pick one of the doors, right? So Monty says, pick a door. The contestant picks a door. So let's just say, for example, that the contestant picks door number 1, okay? Now, this is the key to the whole thing. Next thing Monty would do is say, tell you what I'm going to do. I'm going to show you what's behind one of the doors you did not pick, right? Now, Monty Hall knows what's behind each of the 3 doors. He knows where the car is. So Monty is careful to open a door that has a goat behind it. So Monty, one of the 2 doors at least, if not both, have goats. Monty knows where they are. So he opens a door that has a goat behind it, okay? Let's say again, for example, that he opens door number 2. Door number 2 has a goat behind it. Next, Monty says to the contestant, I tell you what I'm going to do. If you want, I'll let you switch to the remaining door, which would be door number 3 in this case, or you can stick with your original door. All right, hopefully you understand the question or the setup. So now here's the question. Should you switch or should you keep your original door? And there are basically 3 answers you have to choose from here. Option A, it's better to switch. Option B, makes no difference if you switch or not. Your odds of winning are the same. And option C, it's better not to switch. All right, while you think about this, so I've been posing this question for the first lecture of this class for 20 years because I think it's really cool. I actually got it from the newspaper. If you ever get the Sunday newspaper, and it often has this thing called Parade Magazine in it. It's a goofy little magazine. And one of the columnists in Parade Magazine is Marilyn Vos Savant, the world's smartest person. And she always has interesting little tidbits in her column. And this question was put in, or this problem was put in one of her columns. And then she proceeded to say what was the right answer. And then the next week, she published letters from 3 different professors, mathematics professors. I remember one of them was University of Florida, that sticks in my mind, who swore that she was wrong and that they were right and the answer was not what she said they were. All right. I also gave this to one of my PhD students a while back. I told him what the right answer is. He didn't believe me. He actually wrote a computer simulation program to simulate 1 million plays of this game to try and prove that he was right and I was wrong. But of course he lost, all right? So I've given you some time to think about it. How many, raise your hand. So let's raise your hand if you think the correct answer is A. It's better to switch. Okay, it's about half. Raise your hand if you think it's B, doesn't matter. I see 2, and so who thinks it's better to stick? Sarah, did you raise your hand for B, Sarah?
I raised it for the first one.
Okay. Okay. All right, so for me, this is a very difficult problem. Oh, and the other thing I wanted to say, so I've been doing this for 20 years, and then this movie came out. You ever see the movie 21 starring Kevin Spacey? And at the beginning of the movie, they show Kevin Spacey in class, and he's given this exact same problem. And it really torqued me off because I figure he stole it from me, or at least Marilyn Vos Savant. I did not steal it from that movie. So it turns out that the correct answer is A, although many people don't believe it. Not only is that the correct answer, but it's not, it's kind of hard to, I'm going to try and explain it, and I may convince you, I may not. So here's the way I think is the best way to answer the question. So if you agree with the first bullet, then I think I have you, right? If you pick a door and stick with it. So from the beginning, you say to yourself, I'm going to pick a door and stick with it. If you do that, you have a 1/3 chance of winning because one of the 3 doors has the prize. So if you agree with me, then I have you, because since you only have one other choice, which is to switch, if you have a 1/3 chance of sticking with your door, of winning, you have a 1/3 chance, then there's only one other choice. So you must have a 2/3 chance of winning if you pick that one. That's the explanation. All right, the last one, this is one you may have seen before. Given a class of 10 people, what is the probability that at least 2 people have the same birthday? What if there are 20 people in the class, 30, 40? Sometimes probability professors try and earn some money by betting the students on this kind of thing. It's kind of interesting. So when we study counting, we'll study out how to, study how to calculate this. This is the formula. I guess I just want to show you how it kind of works. So let's say you have 10 people in the class, and there's an 11% chance that 2 people have the same birthday. If you have 20 people in the class, it goes up to 40%. 30 students in the class, 70%. 33, that's how many are in the next section of this class. It goes up to 77%. If you have 40% people in the class, it goes up to 90%. Right, so there's 40 people in the class. There's 365 possible days they could have birthdays. It seems counterintuitive that there's a 90% chance that 2 people have the same birthday. But in fact, it is correct, right? All right, so again, the point of these problems are kind of, I find them interesting and fun, but it shows that probability can be counterintuitive, right? These are easy questions to ask, but not necessarily questions where you can even guess the right answer, right? You have to think carefully about it. And then what you have to do is you have to learn probability, right? Because that's really the only way to resolve these. You have to learn how to think about these problems the right way. So that's kind of why probability is tricky. And learning how to think about problems the right way is hopefully what we're going to learn how to do. Now, that is everything I have for today. But before we sign off, I would like to see if anyone has any questions. Feel free to email me. I read my email all the time. Anybody? Okay, so make sure to watch that first lecture video and answer the quiz questions by 2 days from now. All right, I'm going to end the meeting. We'll see you all on Wednesday. Bye.